This question came in 2013 for 1 mark in EC Gate. This is pretty much like a theoretical question. So in a forward biased PN junction diode, the sequence of events that best describes the mechanism of current flow is, if you look at this, so option A says injection. Okay, when you actually forward bias, the first thing that happens is injection of carriers, okay, and subsequent diffusion. That's correct. The carriers, once they are injected, they diffuse through and they recombine with the majority carriers, because the injected carriers are usually minority carriers, which means once they are injected, they become minority carriers on the other side. So let me just pictorially draw here. Let's say we have P side, N side. When we apply positive potential and negative potential, holes are injected onto the other side, they diffuse and then they recombine, because they are holes, minority carriers, they recombine with electrons. The same thing happens when in N side, when electrons are injected, electrons in P side are minority carriers and the majority carriers holes, they recombine. So this makes perfect sense. The option A says, okay, injection first when you forward bias, that's what they said, this is forward biased, okay, and then they subsequently diffuse and then recombine with the minority carriers, okay, recombination of the minority carriers. Now for interest, we can just see the other options. Okay, injection, subsequent drift. This is not correct, because drift is not what happens, because in these regions electric field is not considered, in fact, okay, depending on the doping concentration. Extraction and subsequent diffusion. Extraction is not the point, because we have injection, so hence they cannot be the answer. C and D not, because they're talking about extraction, and here in B they're talking about drift, not diffusion. So option is A.